Good morning, Vera. Good morning, Vera. Could you hear me?
Hello, good morning.
Morning. Maybe Vera can share his video. Good morning, Vera. Could you hear me? Maybe you can share your video at the beginning.
Hi, well, can you hear me?
Yes. Hello.
I cannot hear you. Hi, good morning.
Really?
Aber ich habe keinen Ton hier.
No sound?
Ja, doch, ich muss hören, wann ich reden muss und alles.
No sound?
Can you say something? Maybe I hear now.
Hello.
Hello. Now
morning.
it's good. Morning.
Finally. I think the lecture will be 1 hour. Is that okay?
Okay.
Yeah.
Yeah, should be fine.
And there is a question and answer session, maybe 30 minutes.
Mm-hmm.
Yeah.
Good.
And first, thank you for coming to this webinar.
Thank you for inviting.
First, I will introduce briefly in English and in Chinese.
Mm-hmm.
Good morning and good afternoon. Welcome all to this webinar hosted by ETH and Southeastern University. Today, I'm very glad that Professor Bühlmann will join us. Vera Bühlmann is a Swiss writer. She is Professor of Architecture Theory at Vienna University of Technology, also the Director of the Department for Architecture Theory and Philosophy of Technics. After studying philosophy and English language and literature in Switzerland, she obtained a PhD degree in media theory and philosophy from Basel University. Together with Ludwig Hofstadt, she founded the Laboratory for Applied Virtuality at ETH Zurich. From 2012 to 2013, she was a guest researcher at the Future Cities Laboratory at Singapore. Vera Bühlmann 是瑞士作家，维也纳技术大学建筑理论教授，现任建筑理论与技术哲学系主任。自2010年以来，他与 Hofstede 教授一起在苏黎世联邦理工学院建筑系建立了虚拟应用实验室，建构当下技术背景下的建筑理论。那么 Vera 具有英语跟文学硕士学位，兼修哲学与传媒。09年在瑞士巴塞尔大学获得人文与社会科学博士。那么我第一次和他见面是在09年，当时他来访问东南大学建筑学院。那么在2011年到16年期间，他在 ETH 建筑系任教，曾任新加坡未来城市实验室客座研究员。那么他有多部著作，包括《量子城》、米歇尔·塞尔哲学、《天才星球》等等。那么他还编撰了《新物质主义谱系》以及 Metalyticon 系列丛书。那么 Bühlmann 教授具有广泛的国际合作，那么当前与 ETH 的 Hofstede 教授、希腊雅典大学的数学教授 Teferis 共同创建了跨学科的研究团队。Professor Bühlmann has published a series of books including A Quantum City, Die Nachricht ein Medium, A Genius Planet. She also co-edited the Applied Virtuality book series and Metalyticon books. Today we are honored to have Professor Bühlmann here for our webinar. Today she will give a lecture titled Once Upon a Plenitude, Architectonics and Architecture. Welcome.
Thank you.
Start share your screen. Yeah.
Thank you, Hua. I'm very happy to be part of the webinar. I will share my screen now.
Yes.
Okay. So the title of my lecture is Once Upon a Plenitude. It's on the difference and the relation between architectonics and architecture as a way to give a context to our contemporary interest in computation that is very old and that relates, of course, to philosophy, but is not philosophy. So the theme of this seminar, Digital Architectonics, the role of architecture in times of big data and artificial intelligence, I would like to complement this theme by a rather old citation by a French scholar, Michel de Montaigne, who said in the time when books became industrially produced, so that means when there was an abundance in access to knowledge preserved in books for a very, very wide audience, that a well-built head is worth more than a well-filled head. My point will be that this relation of cognition, so a well-built head, education in terms of theory, is not really only that of an individual person, but has an objective manifestation for our field, architecture, in a corpus of architecture theory that is more than 2,000 years old. And this is perhaps not so natural that there is a field, architecture theory, which doesn't come with modern times and with the 20th century, because it relates basically the state of the art of knowledge in all the fields that exist into architecture. So what I would like to start with is to speak a little on how we can think of what architecture theory is and is meant to be. I will proceed by first making a point by relating it to a an Enlightenment architect and architectural theorist, Kazimir de Quincy. He lived at the end of the 18th, beginning of the 19th century, and he wrote a historical dictionary specifically for architecture. And what he did in it is to distinguish between three different kinds of theory in architecture. One which he calls the metaphysical, which designates the essence of the art, the sources of the rules that are to be valid in architecture. The second one is didactic. It includes didactical treatises, so manuals, if you want. And the third one is practical. And the practical aspects of theory, they relate to very pragmatic aspects of construction and building practice. All three of those are contained by him under theory. And this complexity of an understanding of what theory is and can do is part of why today, especially with computation, theory is, we could say, in crisis. So theory is meant mainly to help either didactic or practical aspects. But what animates it, and what really is the benefit or the profit, if you want, that theory can add to practice, revolves around what Kazimir de Quincy called the metaphysical. How does he mean that? He says, obviously, the object of all theory is to teach. But one can only teach what can be proved. What can be proved to the reason and understanding. But there is a limit to explanation, because everything that can be proved must have crossed a line. And this line, he says, is the mathematical line. The mathematical line is something, when we go beyond, we cannot understand. Yeah, he says, there commences the unsolvable. So this is very interesting for us today when we say mathematics means everything that is calculable. In this old tradition, the mathematics is precisely an index for what remains unsolvable, for what can only be articulated without really understanding. And this is precisely the sense of computation that I want to pick up and to propagate a bit more for our thinking today. So this mathematical line, my point will be, this mathematical line is what we are always conserving in coding. Yeah? We cannot directly speak of the nature of number or the nature of the geometrical forms or these things. We can code them in different ways. And actually the history of mathematics and the history of architecture have always been doing this. So rather than giving a definition of what it should be, this architecture theory, I would like to tell three tales that in the corpus are usually chosen, either one or the other, as a kind of an origin or as a ground. Now, emphasizing this interest in coding, of going beyond what we can explain, I don't think there is a need to decide between these three kinds of stances or of origins of architecture. Rather, each one of them tells us something very interesting. Maybe the first one, also probably the best known one, is related to Daedalus. Daedalus, it's not clear whether he is a mythical figure only or whether he was a real person, but he's called usually the first architect. And Daedalus, he was more perhaps than an architect, a mechanic. So the story goes that in ancient times on Crete, there was a king called Minos, and Minos made a kind of a deal or a contract with Zeus, with the father of all the gods on the Olymp. And the deal was that he can become popular among his people if he has something very, very precious to sacrifice to Zeus. So Zeus gave him a white bull, which was more beautiful than any bull that was known. But Daedalus tricked Zeus. He didn't sacrifice this white bull, but another one, because he wanted to hold on to this precious gift. And this in turn made Zeus angry. So he decided to make Minos's wife fall in love with the bull. And this is the first appearance of Daedalus. He comes as an artisan, as a mechanic, and he fabricates an artificial animal for the wife of the king, such that she can mate with the bull. Out of this comes the birth of a monster. She's called the Minotaur. Yeah, the Minotaur is not properly an animal, it's not properly a god, it's not properly human, it's a monster of which everybody is afraid. So Daedalus again has to save the situation, and he builds the first labyrinth. A labyrinth is a space where there is a center, but one cannot easily find the way out. So it was a kind of a prison to contain this monstrous outcome of the king's cunning and tricking of the gods. So Daedalus, as a mechanic, comes as a figure, and this is what we mean when we say he was the first architect, which always goes beyond this line of what can be true, of what we can understand. He crosses it, but it produces consequences, which then again he has to catch up with and make another trick, build another mechanical machine that can help us just one step further. So this is one of the tales to which we relate architecture historically. Another one, which is a bit less old perhaps, comes from Plato in philosophy. It comes in a text which is called the Timaeus, and the Timaeus is a story of how the demiurge built the cosmos. The demiurge is also called, in this line of tradition, a first architect, the architect of the universe. And what is important here is that the demiurge, in this notion, as an architect, literally means the public worker. So it's from ergos, which means the oeuvre or the work, and the demos, which means the broad public. So the architect is a political person here. And the cosmos then is understood as a building of a construction of all the things there are. And architects from then on are to mimic the order of the cosmos. But there is a third tale. It's the one which I like best, actually, and it comes from rhetorics. It is related to a poet called Simonides, and it is something like the founding story of an ars memoria, so of mnemotechnics, a technical way that we can keep memories safe. The story goes that Simonides was invited to a banquet offered by his patron to celebrate a victory in some kind of sports contest. All the guests had to deliver orations of praise. And the one that Simonides delivered praised not only the patron, but also praised two gods, Pollux and Castor, twin gods, but interestingly, twin gods which are not really biological twins, but half brothers. The patron was very much offended that he didn't stand in the center of the praise. And he was angry at Simonides. And despite of this, Simonides heard a noise from outside of the banquet. So he was attentive to what goes on outside of the social situation that they all shared. And he heard a knocking on the door. He went to answer the door. And in the moment he answers the door, he sees that the two gods have come to visit him. And in the same moment, the building collapses and all the guests and the hosts are dead. And now begins the moment of the ars memoria, because people didn't know who was there. So the families could not give proper funerals to their members because they didn't know who was there. And Simonides, because he had memorized precisely who is sitting where around the table, could reconstruct the entire situation according to a picture of a virtual house that he had kept in his mind in order to keep an overview. And this idea of having a house within our minds, an imaginative, it's often called a memory palace, yeah, to store information, to store what we pick up from a real life situation, such that we can memorize it more easily and access it more quickly, became an entire techniques of how to memorize things. It's called mnemotechnics. And it is at the core of the tradition that is now called rhetorics. So rhetorics has something to do with encoding knowledge and placing it in a virtual structure. That doesn't need to be real. It needs to be plentiful in space, because the amount of information that we can pick up, this is indefinite. And the people who were training in this art, they could memorize books of several thousand pages through such a kind of a technique that would be rhapsodic. All three of these tales stand, if you want, in the prehistory to Vitruv, who was the first architect who wrote a theoretical, systematical treatise of architecture in the 1st century BC. So when the first emperor of Rome came into power. And the interesting thing that Vitruvius now does is he keeps the stories of all of these different backgrounds to architecture, and he models a system very much like the one of an ars memoria in rhetorics, but specifically for architecture. He told the emperor that the empire he is going to build works like a public encyclopedia. So it's a storage space. The built architecture of the empire is going to be a storage space of all the knowledge that was available at the time. And everybody who lived in the empire, through living with these buildings, had access to all of the knowledge. Yeah. So this is the idea of Vitruvius and the foundation of architecture theory more properly. So the city is an encyclopedia. The houses are like books. But what is contained in it needs to be deciphered, because if one cannot read how architecture is thought, people cannot access the knowledge that is inside of it. And that is where the role of language becomes constitutive for architecture to work in such a democratic, in such a public way that kind of takes from all the three different tales that I have just briefly indexed here. So my talk is going to be organized in 5 aspects or 5 sections. The first one now, when properly starting, is to relate this particular role of language, which always needs to be encrypted. Yeah? So it's language which is always coded according to the theory in which architecture is to be understood or read or thought, through philology. Yeah? So not through the history of architecture, not through some directly grammar or syntax or semantics, but philology. So philology, this is my claim, can attend to language as a kind of a natural force, a puissance. Yeah? And this means that philology can say whatever language might be rationally, it is here, and everything that can be thought can be said in a language. Yeah? So in a language, there are all these new words coming. There are always older words being forgotten and then being remembered again. And this is what keeps a language alive, what makes a language a kind of a virtual technology, if you want, before we had computers properly. And philology is a field that undergoes quite an interesting revival contemporarily, because people start to become very interested in language that is not disciplinary. So in language which cannot be reduced to linguistics, so to general theories of what language is supposed to be, to semantics, even to semiologies, but that want to say there is always something self-engendering, something creative happening in language, and this is what we should care for. There has been published a kind of a manifesto for a new philology, I think 2 years ago in 2018, by a German scholar called Werner Hamacher. He published 95 theses on philosophy on philology, excuse me, on philology, and I have extracted from the beginning of these theses a few excerpts to give you an idea of what philology is supposed to be, in order to understand why it is interesting when we want to think about architecture in terms of computation. So he begins by saying, the elements of language explicate one another. They speak for that which still remains to be said within that which is said. They speak as philological additions to one another. Language is archi-philology. Yeah. So when we think about the basic idea in architecture, which is to articulate a building, yeah. So then we can say this articulation of a building is the same term like we speak about in language when we articulate a sentence or we articulate a word. So articulation is what links the two. And the idea is now to think of architecture like philology thinks of expressions in language. He explains further by saying the fact that languages must be philologically clarified indicates that they remain obscure and reliant upon further clarifications. The fact that they must be expanded philologically indicates that they never suffice. They're never clear enough, because every clarification enriches what it can say. Philology is repetition, clarification, and multiplication of impenetrably obscure languages. And this obscureness now is not because somebody wants to keep it obscure, not to keep a secret exclusive, but because at its origin, there can only be tales. There can never be a clarification that can give the grounds for an explanation of it. He furthermore goes on and says, to be able to speak means to be able to speak beyond everything that has been spoken, and means never to be able to speak enough. The agent of this beyond and of this never enough is philology. Philology transcending without transcendence. And this now, so if we say, okay, philology can make sense of words like this, then it is architecture which makes it manifest. Yeah. So it does not only remain virtual, but it becomes corporate. It becomes a body. It becomes a physical organization if we think of the role of language in architecture parallel to such lines in philology. Especially one distinction becomes very precious for our interest, which is to distinguish the role of language in philosophy from the sciences. And the sciences are characterized by the appendix logy, so ontology or biology or geology. Those are sciences, and it means that they treat of logos, so of speech and language, in a way that can be reduced to determining a truth value. So can it be true or can it be false? This is the role of logics. But the role of logos that is at stake in philology, and I would argue also in architecture, is one where there is at the core an affection for things, where a friendship with ideas is central, where there is only ever inclination towards something, a kind of an embracing of what it could be, without a determinate definition of what it is supposed to be. So there is a notion of philia, which means friendship and love in Greek, that can be related to such an understanding of speaking in coded manner. And if you want to have a kind of a genre or an approach to how we can think of such coding, it would be poetry. Yeah. For Werner Hamacher, it would be poetry, because poetry alone is able to speak of something without making it like oneself. So in poetry, we speak of what we don't properly understand, and we articulate what remains impredicable, in a way unspeakable. Yeah. So we make it sound, even so it cannot be grasped. So this is a kind of a pretext. And now, with this understanding, I would like to shortly index what I call 3 legends on the computer. The first one is from 1950, and it plays in France, where the director of IBM the president of IBM in France, had a problem of how to call the computer in French, because the term the computer in French had already been taken by another kind of device, which was much less complex, but much more ubiquitously known. So they needed another word in French for what we call the computer. The French, until today, call the computer l'ordinateur, no? The ordinator. And the story goes that this president of IBM France was having lunch with a famous philologist, Jacques Perret, who was teaching at the university in Paris. And this university was a school where the natural scientists could still be, were in the same school like the humanist sciences, like the philosophical sciences. So it happened that in the encounter of their shared lunch, where they were trying to figure out how they can call the computer, there was a third professor sitting next to them and overhearing their conversation. So their conversation was about whether the computer could be called, for example, a combinator, le combinateur, or a systematizer, le systémateur, or a synthesizer, yeah? Or even they were thinking of funny things like a congestor. So this makes us think, of course, of Kohlhaas with the congestion, but it's about indicating a kind of a process, yeah, that takes place physically. And then, so this is a story that my favorite philosopher Michel Serres tells. This third professor who overheard their looking for the right word said, but I think I have a proposition. What you are talking about sounds very much like the field that he is currently researching. And he happened to be a philologist, but working in medieval theology. And he was working with the doctrine of one scholar who said that we need to think of God as an ordinateur, because God is bringing order to the world, and always that kind of order which makes people comfortable, happy, and protected. And it is this one term which sticks. Yeah? So both this Jacques Perret as well as the president of IBM France accepted that if they think about what the computer should be able to do, it would be something like that. So this is no more than a legend, but it's interesting, of course, to hear about it. The second one I would like to tell you relates to the fact that computation is not only calculus and analytical, as we today usually think in relation to Turing computing and so on, but it actually has always also been mechanical. And the term mechanical has a legacy which is super interesting, because it's quite the opposite of what we usually relate with it today. Today we think when something is mechanical, there is nothing inventive about it. Everything is clear. It happens in clear regularities, always the same, always the same. But the term mechanical actually meant something being full of resources. It meant something inventive and something ingenious, just like Daedalus. Yeah? So he was a mechanic in precisely this sense. And when we think of some very early manifestations of a computer, for example, Gottfried Wilhelm Leibniz's mechanical calculator from the 17th century, this meaning of mechanical was still there, because with Leibniz as well, the building of this mechanical calculator, of one of the first real models of a computer, was strictly relative to the invention of Leibniz of a characteristica universalis. It was a new kind of code. It was a binary code, actually, before the one that we know today, with which he wanted to code all the numbers such that they can be treated through mechanical procedures. And this story has a beautiful coming back, let's say, in the 19th century, with a next version of a mechanical calculator, which was invented by Charles Babbage, a British engineer, who was thinking about this mechanical calculator in terms of what he called a difference engine or an analytical engine. So with him, it was the calculus which was predominant before the mechanical and the alphabetic, so the coding dimensions of it. And he was working with a young woman at the time. She was, I think, barely 25 years old or something like that, called Ada Lovelace. And Ada Lovelace was trained by her mother in mathematics, which is something super unusual. At the time, women didn't have access to universities. But of course, there were always people who didn't see why women should not be educated. And she was a very gifted mathematician, and she saw in the mechanical difference engine that Babbage had invented the potential to be much more powerful by treating the code itself in terms of algebra. So what she invented really was the first idea of a programming language. And this programming language, it took the mechanical carriers, if you want. So it was working with the pinch cards of the weaving industry, the punch cards, and it said all these locations, or virtually in algebra, we can actually stack these punch cards, and they can be variable, definable according to particular constellations. So in algebra, in the abstract symbols, she began to place actions. She began to place not just steps in one rational process, but entire procedures that operate upon these steps. Yeah. So this is why she is also called the enchantress of numbers, because in a certain way she treated these perforated cards with which the mechanical engine was working. She treated them like a memory palace. Yeah. She treated them like an imaginary structure, an imaginary building in which we can place an indefinite amount of indefinitely complex information. This was in the mid 19th century, so more than 150 years ago from now. So with these stories, with this background, I would like now to come to speak about what we mean with an idea in architecture. So how does this relate now to the relation between idea and form? Because obviously form is constitutive for every structure in architecture, but how precisely does form relate to a philosophical notion of idea if we look at it through philology, yeah, through this kind of archaeology within words? And for this, I would like to briefly introduce you to 5 different treatises of what an idea can be in architecture. So the background of the notion of form and idea is usually referred to, again, Plato, to the text which is called the Republic, where he has a dialogue between Socrates and Glaucon, where they are trying to find how to relate to the difference between the idea of something, like the idea of colors, which wouldn't be blue and white and green. So it wouldn't be the addition of all the different colors. Yeah. So a difference between a class or a category and its instances or its particularities. So the problem they face is that in order to have a notion of a color, one particular color, there needs to be a form for what the color is. And then we can say this one color is this, and another color is this, and another color is this. But if we put form on the level of particular classifications, we still have a problem where to put this idea that is generic to all the particular ones, where to put that. It again needs a kind of a form, but then that would mean there is an infinite regress of the form of all forms, which again needs the form of all forms. It's a problem which is very much related to the problem in set theory, where we have the same thing. Yeah. So the set of all sets does not follow the same kind of reason or rationality in terms of precision and exhaustiveness as we would like it to play. So from this relation between a form and a form of forms, we can easily relate if we say, well, both are manners of coding. And of course, we can code things on different levels of abstraction. So then we can actually transcribe or translate from one level of abstraction to another level of abstraction. But this brings the problem that we never really produce one representation that would be truthful. Yeah? So we would always be within a rhetorical domain where the way how we speak of things is biased in a certain way. And this is precisely why Vitruv, when he wrote his 10 books in architecture, took most of his concepts and the structure of how to think of architecture from rhetorics. So this would go too far now to really make it explicit how he takes the structure from people like Cicero or Vitruv, who were great orators, great theorists of how to speak with influence. But at the core is not the distinction into different fields that all make up architecture. In architecture, it is the gnomons, so the clocks or observatories, it is buildings, and it is machines. In rhetorics, it is orations that are for festivities, it is orations that are vulgar speech, and it is orations that have the authority before a judge, so that are happening in legal places. And there is an intricate kind of theory of how we can technically learn to become better in serving all of these different fields into which it is articulated. So if you read something about architecture theory, this kind of structure in Vitruv is what you will find first, because it is a set of concepts that has been picked up by every theoretician, every architect throughout the 2000 years in which it has existed. And to pick it up doesn't mean to reproduce it. Yeah. So every one of them has always slightly changed one of the notions and gained an entirely new system out of it. And this is why the history of architecture is so interesting to trace in this evolution, in this development. It's not an evolution that goes from illiterate and more primitive to elaborated and more sophisticated. It's always already very sophisticated and strictly in proportion to the kind of knowledge that was available in a certain time. Now we make a big step and we relate it to 20th century architecture. One of the most famous texts of that time is by Walter Gropius. It is from 1956 and it is entitled The Scope of Total Architecture. And now we need to be very precise, because usually it is read as the total scope of architecture, but it's the opposite. It's the scope of a total architecture. And when I say it's the opposite, I say it because he introduces the text with a scene of which he says everybody in our lives has experienced this. Every one of us has lied on the ground in nature and studied or contemplated the night sky with the stars and wondered about the perception of an infinity of the universe. Total architecture, in the sense that he means it, always needs to remain open to this infinity which it cannot grasp. And that's precisely how architecture can prosper. Architecture is always the same in a certain way, but still becomes richer and richer and richer in distinctions. So the total architecture is a total only as a model of what we cannot grasp for the Bauhaus. And this manifests in another interesting form. The Bauhaus had strict didactics and methods, of course. We usually relate Bauhaus to a style, and that is completely false. So Gropius, but all the others as well, they insisted that what they are looking for with modern architecture is not a style. It's precisely not a style. Rather, what they are looking for is a language that articulates form in a way that would not be culturally, that would not stigmatize a kind of a cultural habit or a convention, but that can accommodate all different kinds of cultural forms of manifestation. So they were looking for a language that is capable to articulate form. And form, we have seen, is precisely what is at stake between this, one color, two, three different particular colors, and the idea of color. The thing is that we can have form on both of these levels of abstraction. And if we have this, we are in a situation quite similar to the one of us experiencing the infinity, the vastness of the cosmos when contemplating a night sky. But very often today, today's usually historical architecture theorists, they confuse this distinction. They say the Bauhaus was about a language that deals with elementary forms, but it's precisely the opposite. It's a language that is to articulate really the form of all forms of all forms. Yeah. So in German, it's eine Formsprache, not eine Formensprache. And if you look at other protagonists of modern architecture, for example, Kazimir Malevich, we can perhaps better get an idea of what they were after with this. So he coined this term suprematism in art, but also in architecture, for saying we need to contemplate a kind of a perception of which we are capable, but we need to learn to perceive it. Yeah. So how can we perceive something abstract? And how he thought of this was, for example, these are 3 pictures of his series of what he called suprematistic constructions. The first one, which you see on the left-hand side, is a picture depicting what he calls the perception of the universe. The second one is what he calls, one in the middle, the perception of what it means to fly. And the third one, perhaps most astonishingly, because it's not a kind of a natural experience, he says, this is the perception of electricity. It is the form of all forms of how we can perceive things like telegraphy. He had a whole series of paintings like this. And what was important for him was to say the perceptions with which we live in a daily level, they are all mediated by objects, by things. But these objects, they come to stand between us and the night sky. So they cover our sight such that we forget that the universe or the cosmos is so vast. So he wrote another book which is called The Objectless World. No? So a kind of a world where there would only be perception that can be acquired, and this perception comes equally much from technical artifacts as it comes from nature itself. When we speak of modern architecture, of course, Le Corbusier cannot be left out, and it is with Le Corbusier perhaps that our interest in code and scale, and also the human scale, becomes most eminent. So one of the things he is most famous for is this little booklet called The Modular, which he wrote between 1942 and 1955. And what is at the core of this treatise is the problem of metrical transmission of something that cannot properly be grasped. So what he starts out with is sound. He says, it is so amazing that Pythagoras solved the problem of how to transmit. So that means how to keep present something so elusive like sound through a system of notation. He said he took 2 points of support capable of giving both certainty and diversity. On the one hand, the human ear, and on the other hand, numbers. That is to say, mathematics is in all forms. Mathematica herself, Le Corbusier calls the daughter of the universe. So what we have here is, in relation to these different levels of how forms can be coded, there is again the mathematical line. And the mathematical line is not something which wants to oppress us, it is something which helps us to liberate. For Le Corbusier. There are other passages, all of these are from what he called the Preamble. So it's something like that which is to sound first before the play of his text starts to perform. A preamble, and in it, he describes how amazing it is that we have, since Pythagoras, in musical theory, in composition, an artificial scale of how to transmit sound. And what his theory of the modular was mainly interested in was to say, we need in architecture, because in architecture, color or vision is more evidently important than sound. So we should have something like we have for sound, a similarly artificial scale to everything that is visible, to the visible. This is what his modular was looking for. We don't have time, unfortunately, to relate this idea of the modular now to a notion of the canon, which comes from sculpture, and which, of course, he always puts in the center of these scales. So, because the problem is, in music, the scale itself is related to what most people call the cosmic harmonies. And if we do the same for vision, the problem is, what would be the kind of harmony that in which could root the scales which we can extract? And it is a very, very old idea. The Vitruvian man comes from the same idea, that such a kind of a harmony, we need to anchor it in the human being, because architecture is primarily to facilitate a living environment. So there's a humanistic, also a sophistic idea at the basis of architecture. It's again that which relates architecture to rhetorics much more than to logics, in which there must be a notion of the human, in which all the different scales the different artificial scales can be grounded. But how do we imagine these scales? That is the problem that remains with the modular as well. How do we imagine these scales? And with response to this, I would like to make a fourth aspect to the whole topic around what an architectonic book could be in terms of computation. So the architectonic book comes from, I said with Vitruv that there was an idea that the built environment was a kind of an encyclopedia. Now we can think of this encyclopedia as a kind of an architectonic book, but who writes it? No? And who gives the ideas that are written in it? And here comes a notion which is very central until and including Le Corbusier, of the gnomon. And the gnomon is simply, you all know, the stick which casts shadows that can be proportionate to each other if we look at them at the same moment in time. So if we look at the shadow at noon, we can compare the length of the shadow to the length of a shadow that another thing casts, and we have a proportion which needs not say what is the frame of reference for it, because the frame of reference for it is a geometric projection. So this is the notion of a gnomon, and it is precisely the reason why in Vitruv, one of the three fields, so machines, buildings, and gnomons, they were central, because the gnomons, they give us the spaces of projection in which we can find the proper place of things, but also of human beings. And the gnomon, that is, from a computational perspective, the gnomon always works not directly because it constitutes geometry. Yeah? So it is not itself geometrical, it constitutes it. And it does so through a combination of algorithms and mnemotechnics. So with the gnomon, when we okay, I will come back to this and elaborate a little more how we can understand what it means. But first, to contrast this thinking, I would like to say what the architectonic book is not. And for this, I want to refer to Arch Plus, which is probably the most important German contemporary magazine or journal for architecture. In 2016, they had an edition which was entitled 1001 Theories. And what this means, literally, on the one hand, is we are in a digital sophistics. So theories are being combined in order to create a spectacle, in order to curate attention from one field to another, always in the service of entertainment and the consumption of knowledge. So with 1001 Theories, as Arch Plus presented it, there is nothing left of the idea of an encyclopedia where people could really build themselves, yeah, into knowledgeable persons. They became observers of a spectacle that takes place in academia or in other kinds of domains, not in touch with people anymore. But what it is interesting about it are two things. The title, 1001 Theory, comes from a very famous literary text where 1001 nights were there for, there was a woman captured by a kind of a king, and she would entertain the king with stories every night, every night, every night. And as long as she could manage to entertain him, he did not kill her. Yeah. So there is, in the same title, there is something very existential at stake. So we need to keep talking in order to make it again to the next day and again to the next day. And what is interesting now, if we say, okay, but we have in this kind of spectacle theory, curation, entertainment, consumption of knowledge situation, if we really have a digital sophistics, then we can understand that in this sophistics, like in every period of sophistics, new alphabets of coding are invented, new techniques of speaking with influence are invented. And this means also new vernaculars, new languages of usage, of general and broad usage are created. And it becomes a rich resource to find interesting things in. But another stance, and this leads me now more towards, again, this interest in the computational gnomon, is a text also very recent. It came out in 2018 by Valerio Olgiati, a Swiss architect, a very famous Swiss architect. And it's a little booklet which has scandalized many, many people for different reasons, obviously. But one surely is that the book separates between writing and ideating. So I didn't find the picture of the English back cover of the book, but there it says, written by Markus Breitschmidt, who is a kind of a colleague of Olgiati. But on the cover it says, ideated by Valerio Olgiati. So it's a book, and I would say it's an architectonic book, which wants to keep the ideation of the architect through encoding it into a kind of a language which is not immediately expressing the ideas, but trying to make them well known, trying to propagate the ideas without appropriating the authorship of the ideas. This is a very interesting gesture. And it is at the core of what the title says. So, and it's very odd because it's a book, it's written in language, and on a surface encounter, we could think, well, it wants to destroy all theory. It wants to say, do away with all theory, because theory always only produces discourse like we have seen here. And in a way it does. But it is precisely through that exposing an understanding of theory to which I think we have to find a way back to. And that's why I make these big lines of historical tales and fables and legends. Yeah. So the core idea in it is to say architecture cannot work in a kind of a division of labor where one expertise would say the next field what they need to optimize about it. Yeah. So it cannot be that sociologists tell the architects how people want to live. It cannot be that geographers tell planners how the city should be optimally laid out. So all these different expertises, they create a kind of a noise and a discourse through all offering meaningful references, which are just sophistical. So Olgiati says, as an architect, we need to, in a way, cancel out this noise. We need to start thinking again in what he calls a non-referential manner. And this non-referential manner, it means to develop ideas in architecture and ideas in the fully philosophical scope of the word, but in a very particular manner. Namely, he says, all architects should be about developing ideas, but if the ideas are not meant to reference something, if they're not meant to be indexing a kind of a classification system or an ontology of things, then how can we reconnect with ideas? And he says, ideas in architecture must have two aims that lie in a way outside of architecture, but are architectonic. And these two aims are, on the one hand, they have to engender sense. And engender sense is not the same like making sense. It's not imposing a manner of how something needs to be read or thought or understood. Engendering has something creative in it, but also something reproductive and something incandescent. Yeah. So Sinnstiften, this is like a little, no, it's like a fire which could lighten up. So Sinnstiften, that's one aspect. And the other aspect is it has to ideate form. So it has to be computational in order to think about the particular idea in terms of form. And this means to engender form. Yeah? So to ideate form means not just to use form, which is already classified, already there by some kind of expert system that needs to be administrated, but creatively articulate form through ideating it in an original kind of manner. And this understanding now of ideas only becomes graspable in what it implies if we distinguish between architectonics and architecture in front of the night sky. Yeah, so upon a plenitude, something which is too much to really be grasped. And then through relating between these different levels, to be interested in a kind of an extraction and the composition of formal elements in space that don't really represent an order, but articulate an order in a way that, for me, the most easy picture to imagine what this might mean is like when Ludwig cooks a soup, tomato soup, he puts an egg white to make the red soup entirely transparent and crystal clear in the flavor that it has. Yeah, so it's something like a clarification which is chemical or molecular. It's not a clarification which would be true. It's one which creates a taste, yeah? A particular taste. And for this understanding, coding is very important, but coding doesn't necessarily mean digital. So we will come towards the end of the lecture to an understanding of the digital I would like to propose to you. So it's just coding, and coding can have a decimal basis, it can have a hexadecimal basis, or it can have a binary basis. It still is always coding. But of course, dependent on the sophistication of what we can think with in terms of coding. So the power, let's say, of language is larger if we encode it in a binary base, because it can translate between more different kinds of metrical scales than if we do it on a decimal base or on another base. So coding is important, the digital is secondary. And what is important too is that coding always works through copying, but copying relates now to the word, the Latin term copia, which was a word for the plenty, literally. This is again the beauty of etymology. Copia doesn't mean to make a boring double of what already is there. It means to make a double of what is there, but we cannot grasp it. It's too much, copia. And that's why the Latin term copiare, to copy, was related to transcribing, to transcripting. And literally it meant to write in plenty. Yeah. So with this, we can reconnect to a term that has been very central, not only for Le Corbusier, but for all of the modern architecture and modern science too, which is the term of an invariance. So this kind of a copia, we can think of it as an invariance of which we can articulate indefinite many variations. And the main idea which introduced this term was in thermodynamics, when people said the amount of energy in the universe must be finite, but we don't know how much it is. But it cannot be that the amount of energy in the universe at one point grows less or more. So it's always the same, it's invariant, but we can add many different numbers to it, no? Depending on what we are capable to clarify thereby. And this is so interesting because it gives us a very different way of relating to copying or to mimesis and to issues of representation, which have largely preoccupied all this discourse around theory in the 20th century, in terms of semiology, in terms of structuralism, in terms of deconstruction. In all of these different quizzes, there's always a problem of how to think of a picture or an image that is and is not mimetical, that is and is not a copy or a representation. So now back to the architectonic book in the sense I would like to make strong. I have, I think, about 4 more slides. Is it okay if I go a little bit longer? Okay, I assume it's possible. Otherwise, please just tell me. I can wrap it up shortly.
So I think it's fine. It's the time is flexible.
Okay, great. It will not take a lot more time. Thank you. So the notion of the architectonic book I would like to stress is again the one in which the gnomon is central, where a kind of an objective instrument, a device, reads how the universe projects itself onto the plain ground of its inscriptions. Yeah. So the gnomon literally draws the course of a day, the shadows, the play of the shadows of the sun in a cycle of day and night, of day and night, of day and night. So we can say what we can read projectively out of the gnomonic inscriptions is something universal that is not the subjective intention of one person or another. And it is in this sense that a Canadian scholar called Indra Kagismek-Even has recently reactualized this idea of an architectonic book. And in it, she traces how architectonic, and this would be now the level in which we can treat language in architecture, always has also a political ambition. So not just a practical and a craftsman ambition, and also not primarily a philosophical one, but a political one. And she says, for the architectonic book, it is organized around principles, but these principles don't come from elsewhere. They don't come from philosophy or from metaphysics or from rhetorics. They are imitated or copied from these other domains, but brought to the domain of architecture. And here they are architectonic principles, which remain cryptic. Yeah? So we don't know how they can be explained, but we can study how they work. And they work in such a gnomonic way that they facilitate the tracing and the deciphering of how the universe itself operates, how it works or computes, and we can trace it within the projective compass of the analemma, which is the course, the tracing of the course of the sun that inscribes itself into the sand. So it is almost like the idea of the demiurge in Plato, but there the demiurge or architecture would have to know the order of the cosmos. And here, the order of the cosmos is always only traced. We try to get familiar with it, but it will never be one dogmatic understanding of it. And it is in this sense that I would like to suggest architectonics has always been computational, because with computation, the one thing we need to, so the one thing that is constitutive for it is algebra. And algebra always has circular movements. No? In algebra, we are dealing with equations. So we are dealing with, in logics, an equation is a tautology. So 1 equals 1. Why do we have to say it? Yeah? But in algebra, we can articulate this relation by including things we don't know, with unknowns, with by differentiating coefficients, literally factors that work together, but they're factors, so they're not elements, and variables. So values that can vary in the value they take. So what the architectonic person knows different from a craftsman or an artisan, because they also work with the gnomon, but they don't try to understand the reasoning behind its projections. The architectonic person wants to reason about how these principles work. So the architect then is architectonic in a computational sense, because he bases everything on the regularity of day and night, of time that passes, of the cyclical constellation of the stars that reappear, not in a kind of a moment of creation or of origination, but cyclically. That's why it is computational. But still it reasons why about things. And that is what gives it an authority which is of political value and which needs to be of political power, different from what an artisan, a mechanic, or a craftsman can do. To our contemporary time, we can say, no, we have this abundance, this flood of information, an abundance of data. And if we try to hold on to particular points and trace them according to one scheme, we get all mixed up. So things get super confusing because we cannot find any ground anymore. So the gesture that the gnomon can teach us is how to, in the middle of such a whirlwind, how can we take distance to phenomena? How can we hold on and stand up? And rather than trying to follow the movements of the things which we can trace analytically, we let them circulate around us. Yeah. So we begin to incite a kind of a regularity in the center of which we are standing. So we make things circle around because we pay attention to it. If we don't pay attention to something, it will get lost. But this center point is the point now, and this is where I want to lead it, where we have to reconsider again something like the modular or the anchoring of a kind of a possibility of a harmony in the human being. So it is the claim then, and this is the political aspect of computational architecture. In architecture, it's about standing up and face the calculable, not submitting to it. Then architecture is gone and everything is engineering. Yeah. So it's about standing up and facing the calculable, literate in what it means, in all the means with which we can calculate. So literate in all the mathematics and the techniques that it entails. So then, in effect, this means it's not about solving problems, but rather about embracing the insoluble obstacles and remembering what we know of their contingent complexity, such that building a stock of experience, we can learn more and more and more about problems which can never be solved ultimately, but which are definitive for human existence. And this kind of thinking is at the core also of Le Corbusier. He wrote a little book quite late in his life, which is not known very often. It's entitled The Poem of the Right Angle. So you see, it's precisely the gesture of erecting into a vertical stance, but it's a poem because it makes like verses, yeah? It lets things circle around this stance. So it's a poem. There are verses from circling, but there is metrics to it too. And this metrics for Le Corbusier, it could only be accessed through coding. But he invented in this little booklet, which contains 19 paintings and very short extracts of poetry, a kind of a color code of how to bring into constellation the different aspects which are constitutive for human coexistence. And these different aspects, they are, according to the structure of the book, milieu, they are the spirit, so intellect and thinking. They are the flesh, so the soft aspect of the body, not the skeleton, but the sensitive aspect of it. Then fusion of things, character of things, and also the gesture of offering, which of course relates it also to ritual practices, to cults. And then the notion of a tool, an outil, so something which can be used in the service of all of these things. The paintings look like this. So they all, Le Corbusier, in a text that he wrote for urbanism in the US, he said, there is only one sign that the old world, so Europe, can bring to the new world. And it's a sign of that should become the measure for all the urban enterprise in the new world. And the sign is the sign of a day and a night, and a day and a night, and a day and a night, as you see it in this first picture here on the left-hand side. So there needs to be a rhythm behind the meter. And this rhythm, he said of it, it consists of two aspects. So two rhythms, of which he said they regulate our destiny. A sun rises, a sun sets, a sun rises again. So in this kind of rhythmicity, we need to stand upright on the terrestrial plateau, he says, of things perceptible to you, contract with nature a pact of solidarity, and so on. So then the question would be, and this is where I would like to end with, if there is the modular, this man in the cycle of day and night, where is he standing? What is the ground that he can put his feet on? How to think of this ground? I think this would be another detour. I leave it for now because we are running out of time. The point is that, So maybe just like very quickly. So the ground is an ideational ground. Yeah, if architectonics ideates form, what it stands upon is not a firm ground of absolute reason. It is the lofty grounds of ideations which are being kept up again and again. So ideas cast shadows. This was a very strong insight of a scholar in the 16th century, Giordano Bruno, which was picked up by Lambert, who was an Enlightenment pre-Baroque scholar, who coined the term photometria. We can make a matrix that reflects the visual, so the photons. So they were speculations in that time, but today we have a mathematical physics which does exactly the same. And this mathematical physics is photovoltaics, which gives us an abundance of solar energy. No? It just depends on our logistics and our means of keeping it, of storing it. We have quantum physics, electricity, and we have information technology. So this is the principles, if you want, of this lofty ground on which the modular man can stand in the digital domain. So the digital is an ideational kind of continent. So it's a continent where the ideation contains the massiveness of it, so the firmness of it. And I would like to suggest that this continent or this ideational domain revolves around the imaginary axis in mathematics, where a point is never at rest. Yeah? In the imaginary axis, we never have a projection into space. We are always already moved by time, that by activity. So that's what relates it to probabilistics and to electricity. And to project, to make projections into the complex plane of this. And these projections, they are like us in front of the night sky. Yeah? They are not positive copies. They're not positive representations. They are articulations of form. So I want to suggest that the digital, it is a special kind of rational basis for the code, but we should nevertheless think of it in terms of logarithms and exponentiation. And then a logarithm means, okay, we need a rational basis. Ultimately, we can say the natural logarithm, so the Euler number. And exponentiation means we don't represent things, we don't define things, rather we want to raise them to the powers that are immanently theirs. So out of this comes an abstract manner of projecting, of theorizing. Theory literally means make visible, imagine. That is, again, generous and open, but it also means the kind of the balance or the 2 feet of the modular in the digital, they need to keep a delicate balance between, on the one hand, a rational basis, a logarithm, and an exponentiation of a thing. Yeah, so they need to bridge 2 scales, which play together but cannot be reduced to either one. And this kind of balancing of a delicate relation, of a very unlikely and delicate relation, this I would like to suggest is what it means to place something in the world. So to invent something in the digital as a continent, but then to be able to encrypt it in such a manner that it can actually be placed in the world. This I would suggest is how we could think of a digital architectonics. But this delicate balance involves something that is not just formalistic. It involves something that relates to the nature of what it means to be human. And there is this very famous picture where Leonardo tried to make sense of Vitruvi's reference of the human magnitudes. And it is very interesting that there are 2, so with the square and with the circle, there are 2 center points. With the circle, the center point is the navel. So it's a kind of a generic nature. Yeah, humans are universally natural, like all things. It's within the infinite, the compass of the circle. And then there is a rational nature. And the rational nature is related to sex and to reproduction. So it relates to the squares, what can be squared within rationality, but it is always playing together with another form, with a generic kind of nature. Because it does this, it is actually possible for humans to keep delicate balances between things that cannot be reduced to one another. So if we have such an understanding of canon in terms of copiousness, this is my last slide now. If we actually speak once upon a plenitude, and once upon a plenitude in our tradition, in the Western tradition, it is a formula which we usually say once upon a time before we begin to tell stories. But once upon a plenitude would be the same gesture, but not strictly in time or in fiction and narration, but in architectonic articulations. So then the question of your event, namely how to relate to the role of architecture in times of artificial intelligence and big data, it would not be so different from how architects have always related to the intellect. So it is building upon words and intellect. It understands language as a kind of a natural force, a puissance. So language, by definition, can always say all that can be said. So it is always the same story. It is about looking at us or at things in a mirror, in a projection. It is about looking up to things or looking down to things, about moving with winged feet, like Hermes in our mythology, or going with the winds, or hunting in a foreign ground, or cultivating an enclosure, keeping a garden, putting care to certain things, keeping a memory alive, because it is dead if it just reproduces. Keeping a memory alive is something very, very complicated. And also about laughing oneself, laughing about oneself, very important. That is probably what makes such an architectonic, such in terms of a canon and copiousness of computation, human. And this was my talk. Thank you for listening.
Thank you very much, Vera. Thank you for sharing the insights and so rich references. And now there is a question session, but maybe I would like to explain some of your lines in Chinese to the audience. Maybe it's better for them to raise questions because I think most of them first hear you lecture.
Thank you.
感谢大家来听今天的建筑理论讲座。那么我简要的介绍一下Vera 教授今天的主要讲的观点。那么首先他在一开始提出了3类建筑理论，一类是 metaphysical， 就是形而上学。
Ich kann den Screen nicht aufhören zu sharen.
它是指就是讲
Ich kann den Screen nicht aufhören zu sharen.
那么第二个传统是ATTP， 就是指经验性的，我们建筑学里面积累下来的知识跟经验，就是我们一般建筑学学的东西。那么第3类就是建筑实践。然后他讲到建筑理论的一个起源，或者是建筑师的起源，他讲了4点，就是一个是希腊神话 Daedalus， 就是米诺皇宫的建造者，他们认为他也是从西方观点来说，他认为是建筑师的一个鼻祖。那么还有柏拉图的哲学里面也谈到这个建筑的理论。那么第3个是修辞学，那么第4个是我们最熟悉的维特鲁威的建筑理论。那么后面他Vera 提到在西方的传统里面几个重要的技术节点，比如说像阿达 Lovelace 的分析隐形，就是在从17世纪、18世纪，其实运算的模型或者是运算的这个理念已经早就在西方建立了。那么只是到20世纪中期的时候，就真正的物质性的计算机才真正的出现。那么但是运算的思想其实在西方早就存在了。那么Vera 他今天提出，就是他认为建构的理论或者是建筑的理论不是通过，就是不能单单通过 理性的推理，不能单单通过语法的理性建构是能解决的。就是他认为建筑理论还是要通过语言或者是他说的这个语文学来研究。他今天提到一个很重要的概念，就是 Philology， 是一个语文学的意思。那么后面他提到了几个我觉得很有意思的，一个是抽象派的这个画家，就是这个 Malevich。那么一方面他想表达的就是其实建筑的概念并不是能用语言或者是符号精确表达的，它只能通过符号或者语言或者抽象的话来表达概念，但是它这个概念不是完全能够通过逻辑完全说明白的。那么最后他用了一个比较新的建筑师的著作来说明这个事情，就是这一本叫 Non-Referential Architecture。那么这里面就是它是谈论如何在建筑里面表达概念。那么他认为建筑里面的概念，一个是这个概念要合理，就是英语里面可能就是make sense 的意思。那么另外一层意思就是我们有了概念之后要把它形式化，要把它具象的表达出来。那么最后Vera教授认为我们当代这个世界就是数字技术各种理论都非常的多元化。那么仅仅通过运算本身，通过逻辑本身是不能解决问题的。是我们要往前走的话，需要通过语义学，需要通过语言来把我们的维度往前再提升一个维度。现在就欢迎大家在 Zoom 会议室提问，或者是在哔哩哔哩上面给我们提问。Vera, maybe we can look at the question on the chat, in the chat. Do you see it? And
I see it, yes. Do you think architect Luigi Moretti has some relationship with parametric architecture and digital, such as his theory about the mathematic form and structure sequence of space? So I'm not very well familiar with Luigi Moretti's work or his theories, but my suspicion would be that if he writes about mathematics, form and structure, sequences in space, he's not very interested in what today is called parametrics, because parametrics really makes not a lot of sense, except if you want to think of it as a style. No? So if you have this relation between mathematics and computation through coding, then it's always about inventing so a kind of a metrics that is a parametrics with respect to the level it tries to abstract from. So parametrics, parametric architecture would be a kind of this is also how I read the theories. No, with Schumacher, it is bringing architecture to a system theory approach, which foregrounds logics, not mathematics. So it foregrounds logics, where in the lecture I have tried to show you that we can think in terms of philology and rhetorics rather than logics. And then the idea of form remains, still it can be precise, but it remains non-referential. So parametric architecture in terms of the digital, in my understanding, is a reduction of the capacity of computational architecture. It's a reduction which wants to turn it into a kind of a performative style. And styles are, in the sense that we use it today, mainly important in terms of kind of a historical approach, because the styles identify periods or epochs according to the criteria that make up a style. But the styles in antiquity, where people were talking about the orders, they were always meant to be timeless. So in this sense, we have lost how to relate to it. And my proposal is to think of it through computation and architectonic, facilitated by code. But it's a more general understanding of code than binary digital computation, like a series of parametric architecture make use of today. So I'm sure that his work is interested in the digital and also in the mathematical understanding of parameters. So that means structures and graphs, but not in the sense of a style that would demarcate it as a kind of the next thing, you know, for the next couple of years.
Thank you. Yeah, maybe I have one question, because you, in one slide, you mentioned the superior mechanism, the Russia, this artist Malevich.
Mm-hmm.
Yeah, and he has some abstract drawing. Some drawing is expressing the feeling of electricity.
Yeah.
So I found this particularly interesting because, you know, in the architectural school here, we always dealing with abstract geometry or abstract graphics in the first year. In the second year, we use like box, circles, or lines, try to make something sensible or making something beautiful. And here in your storyline, do you mean we should try to express sense, to express feeling, use these graphics, or what's your argument here, or what's the superior mechanism wanted to say about this abstract shape?
Yeah, I'm very, very happy about this question. I know this is a very difficult point. So what I wanted to foreground is that this, first of all, this idea of coding or computation is, in terms of how it influences thinking, decoupled from the computer and computability. Yeah? And what Malevich does is he uses form. He's interested in form in a way that does not crystallize around objects, so logical reasoning of things, but its form directly related to what he calls universal experiences of life, of space, of time, of that all crystallize in an intensity of feeling, so in an artistic kind of a reality, which also means that form can help us to become more sensible in a way. It can help us to have a richer aesthetics. It's not there to form is not there to rationalize in a sense what a certain perception should be like normally or typically, but it becomes a kind of a cornucopia. And Malevich, so this is for us today, this is very paradoxical. How can we be interested in quantification and in form and formalization if we don't want to produce an ontology of objects? So this is not something we are used to think today. But for these traditions, and it goes not only for Malevich, I would say the same for Cubism and for Surrealism as well in different ways, they are all interested in exploring the potential of quantification and form with respect to abstract cognition, abstract intellect, that makes complexity richer rather than reducing it to less. And this is, I find it very important and interesting to reconnect with this thinking today. And Malevich has a very interesting, so he's one, because many people of the artists at that time, they didn't write about what they were thinking. But Malevich is one example who actually tried to express what he cares for with these drawings, with the suprematism in language. Marcel Duchamp would be another reference, similarly interesting for similar reasons. So it's very important not to read art history books which explain to you what needs to be understood about them, but read what they were saying about their things. They are all concerned with quantum mechanics, with electromagnetism, with what does electromagnetism mean for space? No? If space is not a passive kind of container, if it is vibrant, if it is active, if it is dynamical, how can we then think of form in such a context? These are the questions they were interested in, and not in the sense of identifying a different style which will be recognized, but they really tried to rethink what do we do now? We are living in a different physics. We are living in a different world. We can do things that we never were able to before. How does that change what we think is stable and what gives us a comfort? So Malevich's texts are really a very good source to read about these things, and also the notebooks of Duchamp as well.
Thank you. Thank you. Mm-hmm. And we have another question in the chat.
Mm-hmm. Is Ars Memoria or Memnotechnics an analogy of digital storage medium like RAM, ROM, or disk storage? In what part of architecture can we store into computer as a digital form? This is also very nice. So here maybe I can first, before I answer it, I can give you another index to a book which came out last year. It's called The Digital Before, the Digital Outside of the Computer. And it is by Roberto Bottazzi, who is the head at Bartlett School of Architecture of the theory courses. So his book is entitled The Digital Outside of Computers in Architecture. And he draws, especially in Renaissance architecture, you have people like Serlio, but also many others who explicitly began to reappropriate this idea of memory palaces as a kind of a virtual space to store knowledge. So I would say it's not on an explicit direct level the same thing, whether we have a technical career like a CD-ROM or something like that, but in the way that it works, it's very similar. So the memory palaces or the Ars Memoria, it is something that on the one hand can be learned as a technique, so everybody can follow it. It means, for example, when you have to memorize a long text, what Ars Memoria will teach you is, okay, now put yourself, so close your eyes and put yourself in a space which you know very, very intimately and well, where you know what kind of box or what kind of paper is placed in the different niches of that space. So you need to very intimately feel this space in its whole complexity. And then you begin to code the text which you want to memorize. And you say, for example, the first lines which are about this, I put them next to the printer. If I would project myself now into my office. Yeah, I put them in the little green box which is standing right next to my printer. And then the next lines, they need to go below the table. And then I know when I go to next to the printer, I need to touch below the table, and then the text will be back. So it's really a kind of a project. So yeah, it gives you shortcuts between passages that you have decidedly placed in a spatial arrangement with which you feel intimately familiar. And in that sense, we can think we can think, of course, of this coding. So for me to know which passage to put where in my room, we can make an abstract logistical system out of that. Yeah? So I can index, I can encode these places, and then it can be automatized. But then where I place things is in the symbols. So I symbolize places and objects and things, and I put things into this symbol. And in that sense, I think we can say it is similar to how storage technology does it, because it's like we place, Ludger Hovestadt in his talk had this one slide where he said, we can, in cryptography, we literally place knowledge, we keep it secret by putting it somewhere in the enormous unending series of digits of pi, of the irrational number pi. Yeah, so we can, the space is so vast within one number, if we symbolize this one number, that we can place things in it. If we just remember where we have put it, otherwise it's lost. So there are many relations between these things, but they are not simple, and they all depend also upon a kind of an imagination, which of course with the computer is being objectified. So it's the processor which knows where to retrace where things have been stored or placed. But the thing is, and that's maybe important, why? Because we could say, but the computer replaces this old art, no? Because it does it, of course, much, much, much better. So there is no way the human mind could, through memory, through ars memoria, ever become so capacious like a computer is. But the thing is that from relating to information like this, from actually putting it to places, we train. It's like when we do sports exercises every morning, or when we do cognitive exercises that keep our brains alive, yeah, that train it in a physical sense. So the art of memory technique, it trains our different faculties of thinking. It trains our imagination. It trains our capacity to speculate. It trains the range of the associations with which we can deal. So when we practice ourselves in that, we also train our own brains. Yeah, it's not just about outsourcing where our limits are to the computer, because if we don't have any activities for our brains, well, we will not co-evolve with the computer. Yeah. So we need to use our brains in different ways now that the computer does so many things so much better than we do. And this is, in my understanding, why people like Bühlmann or Malevich, they were so interested in relating science now to art. Because in art, there is this aspect of an intuitive creativity, which somehow we can source this out of us sometimes, but we cannot artificially reproduce it. We can artificially reproduce results that have been achieved, but the creative energy is not really part of what we can avail over. And to relate art to science in the 20th century, in my understanding, had a lot to do about, yeah, making different kind of uses of our brains, which before were not feasible. So it was not pragmatic enough. It was a waste of energy for people broadly to engage with these aspects. And now, where the computers can do so much for us, there is it's a liberation. Yeah, it's a kind of a liberation.
Thank you.
You posted the link. This is great.
Thank you. And we have 2 more questions.
Okay.
It's what about the paradigms of architect?
How can you talk about paradigms? Designers have their own paradigms. AI also has its paradigms, how to break through the boundary. Yeah, the paradigms is very interesting. So paradigms, they have something to do with world pictures, of course. No? And then paradigms, so there are things which are shared by all the different fields. For example, mathematics. Today also information theory. Yeah, also language. These are things without which no field can do. So every field, whether it is medicine or electric engineering or whatever, they all deal with language, with mathematics, and today with information theory. So these things, when there are paradigms on that level, they help us to make bridges between the paradigms that manifest in a kind of a disciplinary way. So we can start to relate a paradigm in art history, for example, to a paradigm in social science, if we try to find the same mathematical thinking or the same language theory that would be at work between the two. So it is, I would say, not only a question of how to break through the boundaries of a paradigm, but actually how to be more generous and be able to accommodate different paradigms within a common scope. And this, again, I like about the book by Gropius when he says the scope of total architecture. He says total architecture will take many, many expressions, but there must be one scope that remains common to all of them. So paradigms, when we can reason the paradigm itself. So we can say, not only what does the paradigm tell us that is important, for example, time and space form a four-dimensional kind of new universe. That would be a paradigm. But then we can say, well, how come? Why does it postulate like this? And then we get to the problem of the continuum in mathematics. And when we look at the problem of continuum in mathematics, we have many more options than the one which postulates time is a fourth dimension. So then we can say time is actually materially present in every particle, in every point that makes up the continuum. And then it's not a fourth dimension, it's rather related to a kind of a scalarity that goes through the dimensions. So then there are many more ways. And like this, a paradigm can always be coded or encrypted according to things which it takes as its basis. And then it can be generalized and related to other paradigms.
Yeah. So there's another question about AI.
Okay, since AI helps extract features of architectural forms, such as personal style preferences, etc., promoting the creativity and intuition in computer-aided architectural design. What is your opinion about the technique in helping architects re-understanding or reinterpreting architecture? About the techniques in having, yeah. So this is very interesting because where artificial intelligence and big data, now, for example, I'm thinking now of Amazon. So I buy a lot of books on Amazon, and Amazon has a profile of me, what I like, which works. So it's very annoying. I don't like to be transparent like that, but it works. Yeah, but that is because it's me as a person with my different habits. So it's me as an individual which behaves like that. So if through this kind of reconnecting with the tradition of intellection, let's say, so with intellectual ambitions to think, to imagine things which are unthinkable, yeah, so which has no purpose, it's not directly serving pragmatic aims, but it's very human to engage with it. Through this interest, they can only work if I try to understand things not according to my personal preferences. So this is in one of the very first slides about philology. That is very important. Why philology is so beautiful, because it says in philology alone we can try to understand things by not making them the same to us. No, it's like in poetry, where it's not really us who is capable to express something poetically, but it's a kind of an inspiration, which wherever it might come from, it's not our subjective will, it's not our subjective reason. And where AI technique helps us to build tracks of consistency, so to extract features in architectural forms, this extraction of features, it can serve, I would say, two aims. One aim would be, it gives us more a heightened sense of distinction. So we can include regularities at levels of expression on certain frequency spectra, for example, where before we couldn't, because we couldn't picture it, we couldn't visualize it, we couldn't hold on to it, we couldn't get a graphic inscription of it. So now with the computer we can. So it means we can make explicit a much vaster complexity of aesthetic factors, let's say. So we can think more complex. So there is really a very interesting, important way of how computers can help us to think, not just in the sense of they take the thinking from us and do it better, but they can help us to think if we work together, if we think together with computers. And in that sense, my opinion is super positive and optimistic. But if we remain tied to an understanding that we always need to legitimate, so we need to have the best model, the best, most widely accepted, the greatest norm of things, and we use AI for giving us representations of this, then it becomes very sinister because we become so influenceable about it. So the same technology, namely feature extraction and dealing with complexity and with simulations, can lead to very different aims. yeah, this is perhaps what I would say as my opinion with response to it.
Yeah, I think it's time is. Yeah. Thank you, Vera, again for the lecture and for answering the questions.
Thanks to you.
And what do you think when we can have the bigger gathering in Nanjing or in Zurich? Maybe.
Hopefully very soon.
Really?
But we don't know. The numbers are not good with Corona. It's not so going so well.
Yeah. Maybe
But
next.
Maybe next year, yes. Yeah.
And in Vienna or in Zurich, do you still continue this big seminar?
We have. So the last time we met was in January, I think, where you were also there in Zurich. And then we didn't meet after that. And perhaps if it's possible, we might plan something for the fall. But it all depends. It's very hard to plan right now.
Yeah. Let's see.
We will let you know, and you are very welcome to participate also virtually, of course.
Yeah. Thank you.
Thank you. Bye.
Thank you all for coming to this webinar. Tomorrow we will continue with Professor Benjamin Dillenberg from ETH Zurich, and his talk is about numerical materials. So see you tomorrow. Bye.